at Processes Session 1 Part 5, which is looking at the materials and jointing which we'd use for drainage pipe. So at the end of this part of the session, I want you all to be able to list some of the materials used for drainage and describe some of the key properties and considerations we should make when installing that material. Identify the fittings used specifically for jointing plastic drainage pipe and describe how to use them, how to use the fittings, how to fit the fittings. And also I want you guys to be able to state the clip distances for drainage pipes. So we're firstly going to look at cast iron very briefly. You use it very occasionally for soil pipes. Mainly it's found used in older buildings. You may need to replace it. You may want to replace it with plastic. It's much easier to work with, depending on what the customer wants, I suppose. Yeah, so we come across cast iron mainly in older properties, but also potentially in industrial properties, maybe car parks, places like that. You'd use cast iron because it's really strong. You may also come across it as in gutters and rainwaters. Again, it's not used so much in modern properties, but in older properties, it's still used. You come across it. Cast iron, we cut cast iron using chain cutters. It's very strong material, very hard to cut, but it's also still quite brittle. And you can use these chain cutters to cut cast iron as well as clay pipes, which are also quite hard but quite brittle. You're looking now at plastic drainage pipes. Well, all the plastic pipes that we've looked at, the plastic pressure pipes that we looked at earlier on in this module, and these plastic drainage pipes, they're all considered to be thermoplastics, which are plastics which can be softened by heating, and they all share the same characteristics: strong resistance to acids and alkalis, good thermal and electrical insulation properties, but they are all affected by sunlight. If the UV rays go on the pipe for too long, the pipe starts to fade and become brittle. It's known as UV degradation. PVC, it stands for polyvinyl chloride, and variations on PVC, UPVC, which is unplasticized, polyvinyl chloride, MUPVC. They're all rigid-walled pipe, though they would be softened by heat. And they can be used for larger bore soil pipe work as well as the smaller bore waste pipe work. ABS, again, is rigid walled. It stands for acrylonitrile butadiene styrene. I always have trouble with that one. It won't come up in the test as the full name, just as the shortened version. So ABS has got rigid walls. We generally use it for smaller bore waste pipe work. Interesting point about ABS, it is the one that's most susceptible to UV damage. Okay, so we'll remember that because guilds like to ask that one. Here, polypropylene is only used for waste pipes, like the ABS. But interesting fact about this, polypropylene has got a slightly smaller external diameter. Internal diameter is the same, and there's specific fittings that you should only use with polypropylene. You cannot solvent weld polypropylene. You can only use push fit fittings or compression fittings to joint it. So yeah, basically all of these pipes can be cut with either plastic pipe cutters, these things here, or with a hacksaw. Just like with anything, if you cut it with a hacksaw, you need to deburr it afterwards. Briefly looking at jointing procedures, solvent weld fittings, we can joint ABS PVC with solvent weld cement, and this is what the solvent weld fitting would look like. And we can also joint it with compression fittings. Again, you can see the compression fittings just here, the sort of ribbed nut on there to allow you easily to be able to easily grip it. Okay, and this one here would be used exclusively for polypropylene. This one, though, you can get different push fit fittings which would fit ABS and PVC. Alrighty, so you can easily identify solvent weld because they don't have any rubbers in the fitting. You make the seal using solvent weld cement, and you need to make sure that you put the solvent weld cement onto the fitting and onto the pipe before you make the joint, and then also give them a little just slight twist to spread the cement during the jointing process. So yeah, make the joint in as quickly as possible before the solvent cement dries out, and also make sure that you do it in a well ventilated area, because the fumes from the solvent cement can give you a head burly. Okay. Compression joints can be used on all types of waste pipes. You can identify them by the ribbed nut and the rubber seal inside. You can see the sort of ribbed nut there on the outside, and then it's kept watertight with that rubber seal. Push fit jointing. You can use push fit fittings. This one on the left would be only for polypropylene, but this one here, that looks like it's for either a 3-inch or a 4-inch pipe, PVC pipe. So it's perfectly okay to use push fit with PVC, ABS, and polypropylene. Just make sure that you use the correct type of fittings for each one. Okay, you can see on the right hand side here we've got a 4-inch T or a branch, which would be used for PVC, for PVC piping. But the key thing to remember, with whatever type of push fit jointing you're doing, make sure you chamfer the pipe first, and you can see that here. Just taking that square edge off, just to put a bit of a slant on the edge of the pipe, so it will slip more easily over the rubber of the fitting. We'd also need to make sure we use silicone-based lubricant over the end of the pipe, so it pushes more easily over the ring. And this is one that guilds like to ask about. Okay, according to City and Guilds, whenever we make a push fit joint, we should always pull the pipe out 10mm. So we'd make a mark on the edge at the depth of the slip, like you can see up here, and then we'd sort of pull that out 10mm. That would allow for a space for thermal expansion. Okay, you also do this with gutters as well. I mean, this is something that you really would have to do it with. With gutters, they've got a mark in them which say insert to this mark, which is 10mm short of the centre of the fitting, and that is to allow for thermal expansion, because it's up on the roof, gets heated up a lot, big variance in temperature between when it's cold and when it's hot, which means that it expands and contracts quite a lot. Okay, now we're briefly going to look at fixing drainage pipes. We've got a slightly different consideration when it comes to fixing drainage pipes, because essentially because the water runs through them due to gravity only. You know, they have to be run at a slight gradient towards the stack. And we're going to look at what these gradients are. Well, which one do you think's the correct fall? Number 1 is flat, there's no slope to it. Number 2 is falling between 18 and 90mm per metre. That means, like, for every metre it runs horizontally, it would drop some distance between that 18 and 90mm. An example I've put there is 20mm. And 3 has got a slope steeper than 90mm per metre. So number 1 is a no-no. If there's no slope, then the water won't flow out. Number 2 is a big tick. That's what we want, really. It means that the liquid would drain and the solids would also drain. It's called self-cleansing velocity. The water would be running at the self-cleansing velocity, so it's travelling fast enough that it takes the solids along with it, and not too fast that the water runs away, leaving the solids behind. And if it's more than 90mm per metre, then the liquid would drain too quickly and leave the solids. We know the falls for soil and waste pipe work, so we're going to look now at the clip distances. Well, you can see what happens if it's not clipped correctly. The pipe will just sag. You'll end up with a build-up of water and solids in the sagged area, which will block. So we're going to look at these clip distances now. They're pretty similar, fairly easy to remember. 32mm horizontally 0.5 metre, vertically 1.2 metres, and 40mm is exactly the same, 0.5, 1.2, and then a 4-inch or 110mm is 1 metre horizontally and 2 metres vertically. Now it is time for your task.